Hello everyone, welcome again. So today we will learn about the delay function and why we should avoid it into our code. Okay, so I have already constructed a very simple circuit, consists of Arduino Uno, push button and few of LEDs. Okay, so this button connect to the input of the Arduino, and the Arduino controlling these two LED. The rest of LEDs actually I haven't connected to anywhere, but I'll focus only on these two LEDs I connected to the two pin out of the Arduino. Okay, so this LED, the red LED, it will be on for 3 seconds and will be off for 1 second. Okay, on for 3 seconds and off for 1 second. And at the same time, I program this button to be active, to activate this LED, the second LED. If I press the button, this LED should be active. Okay, but from now I use the delay function in this code and this example. So when I press the button, see the LED doesn't work. Why? Because of the delay function is blocking the execution of the code inside the Arduino. Okay, so now whenever I press, it doesn't do anything. But to prove that it works, if I press, now it's on, off, when come on again, now it's on. If I press and hold, now it's on. Why? Because it's executed the delay function for the on, then finish, then go to the delay function for the off, finish, then it will just like repeat it the code again, then it will trigger the LED by using signal from the button. Okay, this is the trick, or this is the blockage that happened because of the delay that we should avoid. Okay, so later we will move on to the laptop to learn how to avoid and how to solve this problem. Again, if I normally press, you see the LED, it doesn't work, it doesn't blink, doesn't follow the button. But if I press and hold, unless the full cycle of the code is finished, which is on, off, then go again, here we go, it will start the LED. Okay, so let's move on to the computer and learn how to solve this issue. Okay, so welcome again. So this is the normal and the default code that you will find in the Arduino when you want to use the delay function. Okay, so as you can see here, I define an input button in pin number 15, which is A1, and also two LEDs on pin number 10, pin number 13, and here I declare them as output for the LED, and input will pull up for the input, which is the button. Okay, and in the while loop, I use a normal blink example to turn on the LED, wait for 5 seconds, then turn it off for 1 second. Okay, after this loop will be executed, then I will check if the button's press is mean I got 0 from the button. This one's active low because OD pull up, so when press will be low. Then I will activate or turn on the second LED, otherwise I will keep it off. Okay, so this means if the button is pressed, then the LED will be on, otherwise it will be off. Okay, so when we use this code, as we saw just now, these two functions, the delay function will block the execution of the rest of the code. Okay, so example, this one, when come to the loop, first of all, the LED will be high, then it will be stay here for about 5 seconds without doing nothing. Okay, so the processor is doing nothing, just waiting for 5 seconds. Then keep it low again, then again wait for another second, then it will come to check this condition if you press. So that's why we have to press and hold. Okay, press this button and hold for about 5 or actually 6 seconds until all these commands to be finished, then it will be executed here. Okay, this method of code execution is called the round robin. which is face this problem which call a delay blockage. So therefore this is really no suggested method of using delay in the coding. So therefore I have changed or I have write new function to solve this issue. Okay, same also I'm using the same pin out, pin number 15 for the button, pin number 10, 13 for the output. But here I define new variable called state and I assigned as a low, and also I need to use unsigned long previous ms millisecond equal to 0 and also constant long interval equal to 3000. This interval, it will hold our delay, okay, because we are not using delay anymore, but we will use this interval to store the period of waiting. Okay, how long you want to wait or how long you want to simulate your delay function, you should put your value here. And remember, the value should be in millisecond. Okay, and then in the setup, I define again 2 LEDs output, 1 input as pull-up. Okay, the changing starting from here in the loop function. First of all, I will read the current millisecond. Okay, the current millisecond, the current time in millisecond inside the CPU, which inside the Arduino or the Atmega, which is the main CPU for the Arduino controller. Then I'll store this millisecond reading inside the current millisecond. Then I will check if the current millisecond minus the previous millisecond, which is previous one is 0 because we assume this is the first time you run the code, then it should be more than or equal than the interval you have set here. Okay, this means it will count from the current until reach more than 3000, which is equal to already is mean it's simulating that you already wait for 3 seconds or 3000 millisecond. Then if already succeeded to wait or to count more than 3000 or equal to 3000 millisecond, which is, I mean, the current millisecond plus the 3000 millisecond, then it will store the current for the next cycle. It will store in the previous millisecond. Then it will toggle the state of the LED. This is the state that we already declare here, that low. It will toggle it, or you take the negative of the state, which is become as high. Okay, and then we send this state or this data to the LED. Okay, whether it's high or low, to turn on and off the LED. After that, then because from here we have finished the delay function. That it's not actually not delay function, the function that simulate the delay function, the normal delay function. Okay, then we can peacefully check our input and trigger on or off the second LED. Okay, by using this method, the code will not be blocked at any state, whereby it will be executed continuously without waiting. Okay, because this function or this condition, it will solve the issue of the delay. It will be always come to this condition, check if it's already exceed or equal to the interval that we have set, then it will be go inside this if statement and execute the code. Okay, so with this code we will see later that we can maintain the LED to be blink at, let's say, 3 seconds. Here I set to 3 seconds, or even we can change, let's make it, let's say, 5 seconds. And at the same time we can trigger this LED at any time without waiting the 5 seconds to be over. Okay, so now we can hit upload, Okay, and let's go again to our bench to see how it's behaved. Okay. Okay guys, so as we can see here, okay, we have already uploaded the code into our circuit. We still maintain the same circuit. Okay, so now this LED is blinking at each 5 seconds. Okay, blinking on and off, and at the same time we will see when we press this button, here we go, this LED still can be controlled very smoothly without affecting the first one, or even the first one not affecting the second one. Okay, by using this we already overtake the delay issue or delay blockage issue. Okay, before that, when we press this button to activate this LED, the delay of the first LED is blocking the execution of the following code to activate the second LED. Okay, and with the new update of the code, now we can control the function of the second LED or any other function very smoothly. Okay, so that's why please take a good care and take a good note of the delay function and how to carefully use it in your code. Okay, not everywhere and every time you can use the delay, whereby in some critical situation the delay is not suggested to be used. Okay, so with this we conclude our tutorial for today. Please let me know if you have any doubt or any questions, and see you soon later.